Hello my dear students, in this lecture we will see another theory of failure, which is nothing but saint-venant theory or maximum principal strain theory. It is also called maximum principal strain theory. Now in this theory, the maximum principal strain is used as a design, that is Emax is used for design, right? My dear students, let us consider three dimensional loading in which the principal stresses are sigma 1, sigma 2 and sigma 3. Let us consider this three dimensional loading. Here one principal stress is sigma 1, another principal stress is sigma 2 and another principal stress is sigma 3. For such type of loading, for this three dimensional loading, the strains from these formulas I am considering directly from strength of material. That is, strain E1 for such type of loading is sigma 1 by E minus mu sigma 2 by E minus mu sigma 3 by E where E is Young's modulus or modulus of elasticity. It is also called modulus of elasticity, and mu is Poisson's ratio. Which is nothing but minus lateral strain divided by linear strain that you know, right, from strength of material. Again E2, another principal strain, is equal to E2 is equal to sigma 2 by E minus mu sigma 1 by E minus mu sigma 3 by E. Again E3, another principal strain, is sigma 3 by E minus mu sigma 1 by E minus mu sigma 2 by E. This is how we have to write principal strains. E1, E2, E3 are principal strains if sigma 1, sigma 2, sigma 3 are principal stresses. Now let us consider sigma 1 is major principal stress, which is greater than sigma 2. Sigma 2 is intermediate principal stress, which is greater than sigma 3, and sigma 3 is minor principal stress. Therefore, if this relation is provided, that is sigma 1 is greater than sigma 2 is greater than sigma 3, then definitely E1 will be more than E2 will be more than E3. E1 will be more than E2 will be more than E3. Therefore, E1 is major principal strain. E1 is major principal strain, which is nothing but Emax, and this Emax is used for the design. This E1 is equal to Emax. This Emax is used for the design, right? Now for 1D loading, let us say if the loading is 1D, let us say this is a stress sigma, then what is Young's modulus? For 1D loading, Young's modulus is nothing but normal stress divided by linear normal strain. Young's modulus is normal stress divided by linear normal strain. From this, the linear normal strain is equal to stress divided by Young's modulus. Now if this stress becomes equal to SYT, if applied stress becomes yield strength, then this will be the strain at yield point. Strain at yield point is nothing but SYT divided by E. Therefore, strain at yield point under simple tension is nothing but SYT by E. Because for ductile material, yield point is considered as a design point, or yield point is a strength of ductile material. Therefore, as this is a theory regarding strain, therefore at yield point we have to calculate strain also. Strain at yield point is equal to SYT divided by E. Now we will see how to use this theory for ductile material and brittle material, but we will see for ductile material as of now, because brittle material the strain is very negligible, the deformation in brittle material is very less, therefore the strain in brittle material is very less. Therefore the theory generally we have to define for ductile material. Now let us consider ductile material. For ductile material, the theory says that the write down with me, here I am writing the statement of theory. A component subjected to complex state of stress, a component subjected to complex state of stress is said to be failed if maximum principal strain principal strain, that is nothing but E max, maximum principal strain at a point in a material, at any point in a material, exceeds the strain at yield point, that is strain at yield point under simple tension. This is the statement for the theory. Therefore, as per statement, we can say if this maximum normal strain at any point in the material is more than strain at yield point, then ductile material fails. Therefore, to avoid failure, we have to consider, to avoid failure of material, this maximum normal strain in the component must be less than or equal to strain at yield point. Therefore, for design, with considering suitable factor of safety, this maximum normal strain must be equal to strain at yield point divided by some factor of safety. This is how we have to design the ductile material. Now, my dear students, this Emax, if is equal to E1, then what is E1? E1 is sigma 1 by E minus mu sigma 2 by E minus mu sigma 3 by E right, for complex state of stress. Therefore, we have to equate this Emax with E at yield point. And what is E at yield point? It is nothing but stress at yield point, that is nothing but strength at yield point, SYT divided by Young's modulus E, SYT by E. Therefore, equate these two theories. Therefore, if I equate these two as per theory, for this theory, if I equate these two, that is E max and E at yield point, as per the theory, what will be the theory? What is the theory? This theory is stating that this E1, which is nothing but E max, is equal to E at yield point divided by factor of safety. Therefore, sigma 1 by E minus mu sigma 2 by E minus mu sigma 3 by E is equal to E at yield point is SYT divided by E into factor of safety. Now, from both sides, E will get cancelled. Therefore, sigma 1 minus mu sigma 2 minus mu sigma 3 is equal to SYT divided by factor of safety. This is the theory for 3D loading. Right. If loading is 2D, for 2D, two-dimensional, we have to consider one of the principal stress equal to 0. That is sigma 3 is equal to 0. Therefore, theory becomes sigma 1 minus mu sigma 2 is equal to SYT divided by factor of safety. This is the theory for 2D loading. Now, regarding validity of theory, this theory is not valid for both ductile as well as brittle. Means this theory is not used for ductile. We cannot use for ductile, as well as we cannot use for brittle material also. This saint-venant theory or maximum principal strain theory is not valid for both ductile as well as brittle material, because this theory gives false results. For example, how this theory is giving false results? See here, if I consider uniaxial loading, the stress is along only one axis, sigma. Therefore, for this, what will be Emax? Emax will be sigma by E. Max by E. And if I consider biaxial loading, let us say stress is along x-axis sigma. Let us say this is sigma 1, and along y-axis sigma 2. Let us say sigma 2, sigma 1, sigma 2. And in uniaxial loading, along x-axis, let us say sigma 1. Therefore, Emax for uniaxial loading is sigma 1 by E. Now, for biaxial loading, what will be the Emax? For biaxial loading, if sigma 1 is greater than sigma 2, if sigma 1 is considered as more than sigma 2, then it will become sigma 1 by E minus mu sigma 2 by E. Now, means for uniaxial loading, it is sigma 1 by E, and for biaxial loading, it is sigma 1 by E minus mu sigma 2 by E. Means here, from calculation, you can say E of uniaxial loading is more than E of biaxial loading. Means in case of uniaxial loading, there will be a maximum strain than in case of biaxial loading. But means as per theory, uniaxial loading is weaker. As per theory, uniaxial loading is weaker. But in reality, my dear students, in reality, can you imagine that in uniaxial loading, the stress is only sigma 1, but in biaxial loading, the sigma 1 and sigma 2 together are acting. Mean in reality, the maximum loaded component is biaxial. In reality, here the maximum loaded component is biaxial. Means in reality, biaxial must be weaker. In reality, biaxial must be weaker. But as per theory, as strain in uniaxial is more than strain in biaxial, as per theory is saying uniaxial is weaker, which is false result. Therefore, this saint-venant theory is not applicable for both ductile as well as brittle material. And the theory says that for 2D, sigma 1 minus mu sigma 2 is equal to SYT divided by factor of safety. Right. Now, for this theory, we have to see graph. For this theory also, we have to see graph. What will be the graph for saint-venant theory or maximum strain normal strain theory? Maximum normal strain theory. Now see, we will draw a graph for this theory. Now again while drawing graph, I will consider sigma 1 on x-axis towards right, positive sigma 1, towards left, negative sigma 1, that is compression, right? And sigma 2 I will take on y-axis, right? On y-axis I will take sigma 2, right? Now here let us say if tensile, then upward sigma 2, if tensile, upward sigma 2 plus sigma 2, if compressive, downward sigma 2 minus sigma 2 Now for this theory, what is for this theory, we are drawing graph and we are considering ductile material. For simplicity or for calculation, we are considering here ductile material. For ductile material, the strength is corresponding to yield point, that we already know, right? Now the theory for 2D loading is sigma 1 minus mu sigma 2 is equal to SYT divided by factor of safety. Right? Or the directly we will explain the theory. Let us say case A. Case 1. We are considering both tensile. Sigma 1, sigma 2, both tensile, like stresses, that is both tensile. Let us say this is sigma 1 and sigma 2 and sigma 2. We are considering both tensile, right? Now here what is E1? E1 is sigma 1 by E minus mu sigma 2 by E. And what is E2? E2 is sigma 2 by E minus mu sigma 1 by E Now A case, if sigma 1 is greater than sigma 2, definitely E1 will be greater than E2. Therefore, E1 is equal to, can I say, sigma 1 by E minus mu sigma 2 by E and this we have to equate with yes, E at yield point divided by factor of safety, which is nothing but SYT divided by Young's modulus into factor of safety. This already we have explained, right? Now therefore, in a denominator E will get cancelled. Therefore, equation will become sigma 1 minus mu sigma 2 is equal to SYT divided by factor of safety. First equation becomes sigma 1 minus sigma 2 is equal to SYT divided by factor of safety. Considering factor of safety is equal to 1, because we have to find maximum limits. Therefore, considering factor of safety is equal to 1, the equation becomes sigma 1 minus mu sigma 2 is equal to SYT. And this is the equation of line. Therefore, we have to draw a line which satisfies the equation sigma 1 minus mu sigma 2 is equal to SYT. Therefore, while drawing this line, we have to find the coordinates of this line, right? Let us say A, in this first I am considering if sigma 1 is equal to 0. Then can I say sigma 2 will be equal to minus SYT divided by mu. Therefore, for first case, what is the coordinate? Let us say this is a point A. Let us say this is a point A. What are the coordinates? 0 comma minus syt by mu. 0 comma minus syt by mu. Now second thing, if I consider sigma 2 is equal to 0, if I consider sigma 2 is equal to 0, then put in the equation, then I will get sigma 1 is equal to syt, sigma 1 is equal to syt. Therefore I will get another point B for which coordinates are syt comma 0, syt comma 0. Therefore the line sigma 1 minus mu sigma 2 is equal to syt passes through the point A and B, because A and B both satisfies line sigma 1 minus sigma 1 minus mu sigma 2 is equal to syt. Therefore plot these points. Therefore plot these points. Therefore A point is 0, A point is 0 comma minus syt by mu. Let us say here minus, this is a A point. A point is 0 comma minus syt by mu. This is a A point. Now B point is syt comma 0. B point is syt comma 0. Mu is less than 0.5. My dear students, mu is less than 0.5, 0.5. Therefore minus syt by mu. Therefore syt by mu is more than syt. Definitely, definitely. Some while drawing we have to draw schematically. Therefore here I am dictating mu is less than 0.5. Therefore point B. Therefore B is syt comma 0. Here there will be a point B. B is nothing but syt comma 0, and line passing through AB. We have to draw a line passing through AB. This line, this line. Now this line is passing through AB. Now for this line, what is the equation for this line? The equation is sigma 1 minus mu sigma 2 is equal to syt. This is the equation for this line, right? We can extend this line on both sides. Now again we have to draw another line. Here what in A case what we have considered? In A case we have considered that sigma 1 is greater than sigma 2. Sigma 1 is greater than sigma 2. But if what happens if sigma 2 is greater than sigma 1? But if what happens if sigma 2 is greater than sigma 1? Let us draw another line with considering sigma 2 is greater than sigma 1, right? Therefore here I am assuming B case sigma 2 is greater than sigma 1. In this case E2 will become be more than E1. E2 will be more than E1. Therefore E2 is nothing but E max. E2 is nothing but E max, which is nothing but sigma 2 by E minus mu sigma 1 by E. Now this E max we have to equate with syt divided by E into factor of safety as per theory. This E max we have to equate with syt divided by E into factor of safety as per theory. Therefore in denominator E will get cancelled. Therefore equation becomes sigma 2 minus mu sigma 1 is equal to syt divided by factor of safety. Now consider factor of safety is equal to 1. If I consider factor of safety is equal to 1, the equation becomes, because we have to draw maximum limits, we have to plot maximum limits, then equation becomes sigma 2 minus mu sigma 1 is equal to syt, and this is again equation of line. This is again equation of line. Therefore while drawing this line we have to show the points. We have to find any 2 points to draw the line. These points must satisfy this line. Therefore first, while satisfying this line, first if I consider sigma 1 is equal to 0, if I consider sigma 1 is equal to 0, then I will get sigma 2 is equal to syt. Sigma 2 is equal to syt. Therefore I will get C point. I will get C point. Coordinates are 0 comma syt. Coordinates are 0 comma syt. Now second, if I consider sigma 2 is equal to 0 and put in the line equation, then I will get sigma 1 is equal to minus syt by mu, minus syt by mu. Therefore the coordinates of, let us say, D point, coordinates of D point are minus syt by mu comma 0. Now plot point C and D on the graph. Plot point C and D on the graph. Therefore C is 0 comma syt. C is 0 comma syt. Therefore somewhere here C will be somewhere here. Let us say this point is C, having coordinates 0 comma syt, and point D is minus syt by mu. Point D is minus syt by mu. Now the point will lie somewhere here. The point will lie somewhere here. Let us say this line, if I extend minus sigma 1, the point is, we have to draw plot point D minus syt by mu. This is a point D where the coordinates are, at D the coordinates are minus syt by mu, comma 0, comma 0. Now join C and D, join C and D, and extend this line, extend this line, and join this line with previous line, right? For this line, what is equation? For this line, equation is sigma 2 minus mu sigma 1 is equal to syt. CD line is sigma 2 minus sigma 1 is equal to syt. Now these two lines will meet at point, let us say any point. Let us say these two lines are meeting at point, let us say if I write this point as a P point, means P is the intersection of line CD and line AB. Later we will find this point P also. Later we will find this point P also. Now again we have here in case 1 we have considered both tensile. In case 1 we have considered both tensile. Now in case 2 what we will consider? Both compressive. In case 2 we will consider both compressive and we will draw one more two lines. We will draw more two lines, right? Let us now consider both compression. Case 2, case 2, that is both under compression, both compression, like stresses but both compression. Let us consider sigma 1 is compressive, sigma 1 is compressive, and sigma 2 is also compressive. Let us consider sigma 1 is compressive, sigma 2 is also compressive. Now we already know E1 is equal to sigma 1 by E minus mu sigma 2 by E, and E2 is equal to, E2 is equal to, that is strain along 2 is equal to sigma 2 by capital E minus mu sigma 2 sigma 2 by capital E minus mu sigma 1 by capital E, right? Now let us consider in this A, if I consider sigma 1 is more than sigma 2, if I consider sigma 1 is more than sigma 2, then definitely E1 will be more than E2, definitely E1 will be more than E2 under compression, under compression. Therefore E1 is E max, E1 is E max, right? Therefore equate E1 with our loading. Therefore how to equate? This E max is equal to E at yield point under compression, under compression, divided by factor of safety, factor of safety. Therefore E max is sigma 1 by E minus mu sigma 2 by E is equal to E at yield point is, yes, we can say SYC, SYC, because it is compression, because it is compression, divided by E into factor of safety. This is how we have to use. And for ductile material, for ductile material, SYT is nothing but minus SYC, means SYT is tensile and SYC is compressive, but both are same in magnitude, both are same in magnitude but in opposite in nature. One is compression, one is tension. Therefore here if I simplify this, I will get sigma 1 minus mu sigma 2 is equal to SYC is minus SYT, minus SYT divided by factor of safety. Now if factor of safety is 1, if factor of safety 1, then equation becomes sigma 1 minus mu sigma 2 is equal to minus SYT. Again this is the equation of line, again this is the equation of line. Therefore again we have to plot 2 points. Again for satisfying this equation of line we have to plot 2 points. Let us say first point is, let us say sigma 1 is equal to 0, then what you will get? Then sigma 2 is equal to SYT by mu, you will get SYT by mu. Therefore another point, let us say this point is E, let us say this point is E. The coordinates of E are 0 comma SYT by mu, 0 comma SYT by mu. We have to plot this E point, right? Now again second point, for line we need 2 points. Let us say if I consider sigma 2 is equal to 0, then I will get sigma 1 is equal to minus SYT. Therefore I will get EF point which is having coordinate minus SYT comma 0. Therefore draw one line between E and F, draw one line between E and F, and this line will satisfy, this line will satisfy equation sigma 1 minus mu sigma 2 is equal to minus SYT. Therefore plot E point, E point is 0 comma SYT by mu, 0 comma SYT by mu. Therefore E point will go somewhere here, E point will go somewhere here. See here, if I extend this plus sigma 2, if I extend this plus sigma 2, plus sigma 2, then E point will go like here, somewhere here. Let us say here there is a E point, E point. Now what are the coordinates of E point? 0 comma SYT by mu, 0 comma SYT by mu, right? And plot EF point. EF point is minus SYT here, somewhere here, comma 0. Therefore, EF point, the coordinates of EF are, the coordinates of EF point are minus SYT, comma 0, minus SYT, comma 0. Now join E to F. Join E to F. You will find one line. Join E to F. You will find one line. Now extend this line. Extend this line. Now for this line, equation becomes, for this line, E to F line, equation becomes sigma 1 minus mu sigma 2 is equal to minus SYT. Sigma 1 minus mu sigma 2 is equal to minus SYT. This will be the equation of line E to F, right? Because E and F falls on this line, therefore they must satisfy this line equation. Now again, here what we have considered? Here we have considered sigma 1 is greater than sigma 2. Now by considering sigma 2 greater than sigma 1, now for the same case, by considering sigma 2 greater than sigma 1, sigma 2 greater than sigma 1, we have to draw another line. We have to draw another line. Let us consider here, sigma 2 is greater than sigma 1, another case, right? Therefore E2 will be more than E1. Therefore Emax is equal to E2 is equal to sigma 2 by E minus mu sigma 1 by E, which is nothing but we have to equate with, as it is compression, we have to equate this Emax with SYC divided by E into factor of safety, right? As it is compression, we have to consider SYC. Therefore put the values, sigma 2 by E minus mu sigma 1 by E is equal to SYC divided by E into factor of safety, right? Therefore E will get cancelled, and if I consider factor of safety is equal to 1, the equation becomes sigma 2 minus mu sigma 1 is equal to SYC, which is nothing but minus SYT. SYC is under compression, SYT is under tension, but both having same magnitude but opposite in nature. Therefore equation becomes sigma 2 minus mu sigma 1 is equal to minus SYT. Now again this is the equation of line. Again this is the equation of line. Therefore I have to draw one line which will satisfy this equation. Therefore again we have to consider some points. Therefore let us say first point is, if I consider sigma 1 is equal to 0, then I will get sigma 2 is equal to minus SYT. Therefore let us say G point I will get, that is 0 comma minus SYT, 0 comma minus SYT. Second point, in the same line equation, if I consider sigma 2 is equal to 0, then I will get sigma 1 is equal to SYT by mu, and with this help I will get H point having coordinates SYT by mu comma 0, SYT by mu comma 0, right? Now with this G and H as a coordinates, with G and H as a points, we have to draw one line between G and H. Therefore plot this G and H. Now G is 0 comma minus SYT. Therefore somewhere here we will get G point. Somewhere here we will get G point. Coordinates are 0 comma minus SYT, and again coordinates of H are SYT by mu, SYT by mu somewhere here comma 0. This is H point, that is SYT by mu comma 0. This is H point. Now join G to H, join G to H, and if I extend this line, if I extend this line, the line equation, this line equation is sigma 2 minus mu sigma 1 is equal to minus SYT. Sigma 2 minus mu sigma 1 is equal to minus SYT. This is the line, right? Now here I have drawn all the four lines. Here I have drawn all the four lines. Now the area, common area of four lines, the common area of four lines, this area is nothing but safe zone. The common area between four lines is a safe zone, right? This is called safe zone. Now what is safe zone here? What is a safe zone here? Safe zone, can I say this safe zone is a safe of rhombus? Can you look like this? Are you able to imagine this as a rhombus? Therefore for saint-venant theory, the safe zone is a rhombus. Safe zone is a rhombus, right? Now if you want to find corner points of the rhombus, if you want to find corner points of this rhombus, then we have to solve the equations only. Very simple. Now here you have to do school level mathematics. You have to do school level mathematics. your target is to now find corner points of this rhombus, the safe zone of saint-venant series rhombus, right? And we have to find corner points of this rhombus. Now let us say the corner points. Here I am writing corner points as point P is one of the corner point. Let us say point Q, point Q. Let us say another corner point, point Q, another corner point. Let us say point R, another corner point, and point S, PQRS. These are the corner points of this rhombus. And between these points, the red color rhombus, the red color rhombus. See, this is the red color rhombus, right? This is a safe zone. This rhombus is safe zone. Now, if I want to find point P, if I want to point for point P, number one, point P, point P. Now, this point P is the intersection of line sigma 2 minus mu sigma 1 is equal to SYT, and another line sigma 1 minus mu sigma 2 is equal to SYT. For these line, point P is the intersection. Means these two lines become same at point P. These two lines become same at point P. Now therefore, from two equation to unknown, with the help of two equation to unknown, find sigma 1, find sigma 1 and find sigma 2. Now this is simple school level mathematics. Here I am not wasting your time by doing this school level mathematics. You do this calculation. You will find that this P point is having coordinates. This P point is having coordinates SYT divided by 1 minus mu, comma SYT divided by 1 minus mu. This P point will be having coordinates SYT divided by 1 minus mu, SYT divided by 1 minus mu, right? Now, if you solve for Q point, second point, point Q, right? Now, again, for point Q, can I say this point Q is the intersection of line sigma 2 minus mu sigma 1 is equal to SYT, and second line that is sigma 1 minus mu sigma 2 is equal to minus SYT, minus SYT, right? For these two lines, this point Q is the intersection. Now equate these two lines. These are same. These two lines are same because they have common point called point Q. Now with the help of these two equations, if I solve for sigma 1 and sigma 2, then I will get coordinates of point Q as minus SYT divided by 1 plus mu, comma SYT divided by 1 plus mu. These are the coordinates of point Q. Again, if I solve for R point, point R, another corner point of rhombus, then R point is the intersection of line. R point is the intersection of line sigma 1 minus mu sigma 2 is equal to minus SYT, and another line sigma 2 minus mu sigma 1 is equal to minus SYT. Now these two lines become same at point R. These two lines become same at point R. Now with the help of these two equations, if I solve for sigma 1 and sigma 2, I will get the coordinates of point R. The coordinates of point R are minus SYT divided by 1 minus mu, comma minus SYT divided by 1 minus mu. These are the coordinates of point R. Again, if I solve for point S, see this point S is a intersection of line sigma 1 minus mu sigma 2 is equal to SYT. Sigma 1 minus mu sigma 2 is equal to SYT. See this line, and sigma 2 minus mu sigma 1 is equal to minus SYT. Sigma 2 minus mu sigma 1 is equal to minus SYT. Now these two lines become same at point S. Therefore, if I solve for this, I will find that the coordinates of S, are SYT divided by 1 plus mu minus SYT divided by 1 plus mu. This is how we can find corner points of a rhombus. But don't worry, no one is going to ask you the corner points of rhombus. What they will ask you, they will ask what is the validity of rank, what is the validity of saint-venant theory. Validity is saint-venant theory is not applicable for both ductile as well as brittle material. Now next point, what is saint-venant theory and what is the factor of safety as per saint-venant theory? That we have to apply the saint-venant theory. Again, what they will ask again, what is the safe zone for saint-venant theory? The safe zone for saint-venant theory is rhombus, right? This is the saint-venant theory. Thank you, dear students. In next lecture, we will see another theory of failure, that is Hague's theory.